Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 1, Note 7. Today we are talking about the differences between categorical and quantitative data. We're also going to do a couple examples of stem and leaf plots again. This is our last lesson for Unit 1. So here we go. All right, so categorical and quantitative data. Not all data is numerical. So far, the data that we've been working with has pretty much been numerical, but there is data that exists that is not numerical. Some data is not measured with values or numbers. Quantitative data is the data that we are typically used to looking at. It's the data that we measure with values. It's also called numerical data because it's measured in numbers, or in other words, quantities. So the titles of them make sense. Quantity or number. That's what you're looking at when you're looking at that type of data. Some examples of quantitative data are your typing speed, your weight, length, time, test scores. There's tons and tons and tons of numerical data out there that we analyze every day. Categorical data, on the other hand, is data that's measured in classes or categories. This is also called qualitative data. These are things that you answer in words. If you are asked a question and you answer it with words, then it's a quantity. Some options are favorite color, model of car, gender, yes or no, pass or fail. One thing to note about categorical data is that there is also a classification called binary categorical data. Binary categorical data means that there are only two answers, okay? So that means that something like true or false, yes or no, pass or fail. So like this yes or no, this is binary. If you think about the prefix bi means two, like a bicycle has two wheels. A binomial has two terms. It's an expression with two terms in math. So pass or fail is another one that's binary. So binary data has only two answers. If I went into my son's classroom at school and asked all of his classmates, what's your favorite color? They would answer with words: pink, green, black, yellow, orange. Those are word answers. That's what makes this categorical. But it's not binary because there's a lot more than two that they could pick. Model of car, same thing. What's the model of your car? Honda, Mazda, Hyundai. There's a lot of options for model of car. It's a lot more than two, but it's still a word answer. Gender is one that you could say binary or maybe not binary, depending on how you view it. Some people don't view themselves into the binary category of gender. So that one could go either direction, depending on how you look at it. Example 1, it says classify the following as either categorical or quantitative data. If it's categorical, determine whether or not it's binary. So part A, it says, how many hours have you slept in the past 24? If somebody asked you that question, how many hours did you sleep in the past 24 hours? You might answer 6, 8, 9. That's a numerical answer. This is quantitative data. If somebody said, have you slept 7 hours in the past 24 hours? That's an answer that would be a word. If I asked you that question, did you sleep 7 hours last night? Your answer is either a yes or a no. So this is a categorical. It's the same type of question. It's getting at the same thing as part A, but it's phrased a little bit differently. So this is a categorical question. And even further than that, it's a binary because your answer is going to be yes or no. So it's categorical and it's binary. How many states have you visited? The fact that it says many tells you that you're going to answer with a number. So this is definitely quantitative. How many states have you visited? 10, 6, 23, whatever it may be. Are you right or left-handed? I'm right-handed, I'm left-handed. So this is a categorical question. You're going to answer it with a word. Some people argue that this is binary, but I actually argue that it is not binary because there are some people who are what's called ambidextrous. I don't know if I can spell that right, but I'll try. Ambidextrous. I probably did not spell that right. Spelling. But anyways, somebody who's ambidextrous uses both hands. My mom, for example. My mom is left-handed when she writes with a pencil, but she is right-handed when she swings a bat. So she says that she does all of her large motor things like golfing, swinging a bat, throwing a ball. She does all of those things with her right hand. But when she writes or eats, she uses her left hand. So she would be somebody who's kind of ambidextrous because she uses both. All right, day of the week that you were born, that is categorical because you're going to answer either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. And it is not binary because there are actually 7 choices of answers. Average study time in hours. This is time. Anything that is time is going to be quantitative. Okay. And political viewpoint, I would say that this political viewpoint would be categorical. It's not a numerical answer. Some people would, again, argue that it's binary because they're thinking Democrat or Republican, but I, once again, argue non-binary because there's grassroots and independents and all sorts of other parties that may not be as big as Democrat or Republican, but they're still out there and exist. But it's still a categorical response. You're going to answer with a word. All right, so then we also need to talk about discrete data versus continuous data. When we look at quantitative data, numbers, so this is numbers, we are either going to look at discrete numbers or continuous numbers. So here's the difference. Discrete numbers are finite numbers of values. Here's some examples. That means there's no partials, okay? There's no decimals typically, or if there is a decimal, it may be just like a half, but that's it. There's nothing else in between. So some examples of that, number of children per household. If I asked everybody in the school, how many kids live in your house? You're either going to answer 1, 2, 3, 4, 5, 6, maybe 9, maybe 12, but you're not going to answer 4.5, and you're not going to answer 2.8675. Okay, it's a finite number of values because there's nothing in between the 1 and the 2. There's nothing in between the 2 and the 3. Number of questions correct on a test, same thing. That one could even be a half. You might get 4.5 questions correct on a test because maybe you got one part correct on one of them. But you're not going to have a whole lot of decimals in between. It's not an infinite number of values. It's a finite number of values. Number of languages spoken. 1, 2, 3. Okay, so again, this isn't an infinite number of values. You're not going to say, oh, I speak 1.8675 languages. That's not how it works. There's breaks in the data with discrete data. Okay, things stop. The flip side of that is continuous, or having an infinite number of possible values. Continuous data, there are 2 main things that are always continuous. Speed of anything and time of anything. Time is continuous. Even though our clocks only mark individual seconds, there is an infinite number of values that exist between 1 second and 2 seconds. Okay? Ask a swimmer or a track person, a track runner, about time and having time between seconds, because they'll go down to the hundredths or even the thousandths of the second to go between, to see who won a race sometimes. Speed, same thing. On your car, your speedometer, if you have a car that has a speedometer with a needle, the needle travels in the little dial. It's going up the circle. It usually starts on the left and travels up. That's a continuous thing. It's not jumping. You don't jump straight from 55 miles an hour to 56 miles an hour. There is time in between there. There is an increment in between there for each speed. Even though our car doesn't show that or register that, my car doesn't have a dial for the speedometer. It shows me the actual number. So it'll say 50 miles per hour, then 51, then 52, then 53. So it's only showing me the whole numbers, but there's an infinite number of values between the 50 and the 51 because speed is continuous. Speed doesn't jump. You don't jump from 50 miles per hour to 51 miles per hour. It's continuous. It keeps going. Height is another one. We mark our height as 5 feet 4 inches, 5 feet 5 inches, 5 feet 6 inches. Sometimes we say 5 feet 6.5 inches. Even though we're only calling it on the inch or maybe the half inch, there's still an infinite number of values. Your body doesn't just grow a whole inch in one day. Your body grows gradually and continuously. All right, so now we're going to take a look at a few examples and we're going to try and classify some categorical data into either discrete or continuous. And remember, discrete means that there are breaks in the data. Continuous means that there are no breaks. Okay, so ACT scores. ACT scores go all the way as low as even like a 10. I mean, the ACT scores go all the way down to the bottom, maybe even down to 1. I'm not totally sure, but they go up to 36. 36 is the highest score. In all of my life, I've never seen a partial ACT score. Somebody's going to get a score of a 17 or an 18 or a 21 or a 24 or a 28 or a 34. I've never seen a 21 and a half. I've never seen an 11.75. I've never seen a 17.25, okay? There are no partial ACT scores. ACT scores are discrete because there are breaks in the data. Time waiting for a cab in New York City. This could be 2 minutes. This could be 4 minutes. If you ask somebody, how long did you have to wait for a cab? They might say, oh, I had to wait 15 minutes. But was it exactly 15 minutes or was it really 14 minutes, 0.865, or 14 minutes and 54 seconds, something like that. They're going to round up because that's how we speak generally when we're talking to each other, but time is continuous. It might not have exactly been 15 minutes. So this, even though we don't talk in terms of it being continuous, this is a continuous thing. Same with that speed that we talked about. Speed, a pitcher throws a baseball. So if you've ever watched a baseball game on TV or even in the stadium, there's a little speedometer now that tells you how fast the ball was going. 98 miles an hour, 87 miles an hour, 102 miles per hour. It marks them in whole miles per hour, just like our car marks our speed in whole miles per hour. That doesn't mean it was exactly 89 miles per hour. Maybe it was 89.3625 miles per hour, but the speedometer is not going to get that specific, that detailed, just to show us the speed. However, speed is a continuous variable, even though we don't talk in terms of that. Number of movies on Netflix. That's supposed to say on Netflix, sorry. Number of movies on Netflix. So that is something that's going to be discrete. Again, to my knowledge, I've never seen a partial movie on Netflix. They'll never have like half the movie showing or 3/4 of the movie showing, 75%. You either have the movie or you don't. So this is a discrete variable. Height of a plane at cruising altitude. Your captain's going to come on when you reach your cruising altitude of a flight and tell you, hello, we've reached our cruising altitude of 33,000 feet. You're free to move about the cabin. He's going to tell you things like that. But are you at exactly 33,000 feet? No, you might be at 32,497.68275. But he's not going to say that because that doesn't make sense to most people. That's not realistic, and that's not needed. We don't need that level of detail in our normal life. So he's not going to talk in terms of it being that way, but height is one that is a continuous variable. You don't just jump from 33,000 feet to 34,000 feet. You have to gradually increase to get there. All right, so that's our discussion about categorical and quantitative data for today. Now I want to go through and talk about how we find some measures of central tendency given a stem and leaf plot. So we're going to take a look at a stem and leaf plot here, and we're just going to link the stem and leaf plot to our measures of central tendency, which were two different lessons for us earlier in this chapter. Now I'm just putting them, or in this unit, now I'm just putting the two together. So one thing that I mentioned was really nice about stem and leaf plots is that you see all of the data. Each leaf in the data display, in the stem and leaf plot, is its own data point. So every single data point can be recreated. We could recreate this list of data if we wanted to. All of these points are their own data piece. What we have to pay attention to is the key. So in this instance, I'm looking at tens and ones for my stems and my leaves, okay? So this very first data point is a number 1. That's a 1, that's a 2, that's a 2, that's a 3, 4, 4, 4, 4, a 5, and an 8. This one is a 10. Then it's a 10, then it's a 10. and so on and so forth. So our data is all listed out there. So the first thing that we're going to do, because we're finding our measures of central tendency here, these are the things that we want: mean, median, mode, and mid-range. The first thing that I'm going to do is this first thing I do for all of my data. I'm going to count my N. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. Holy buckets. So my N here is 47. Okay. So in order to find the mean, I have to actually go through and add all of these things up. So I'm going to take a minute on my calculator and I'm going to go through and add them. Now it's going to take me a bit, so I'm going to pause my video. I want you to pause your video as well and grab your calculator. So remember that you need to put the stem with the leaf. So that first one is like a 1. Then there's another 1. Then there's a 2. Then there's another 2. Then there's a 3. Then there's a 4. And so on. Okay? And you're going to add all the way up until you get to that 66. Okay? So add all of your data points right now. Pause your video and take a minute to add them up on your calculator. Okay, so hopefully you were able to go through and find the sum there. When I added up all of my data points, I found a sum of 1,235. And remember that when we find the mean, it's the sum divided by the n. So 1,235 divided by 47, and that gives me a mean of 26.2765, blah, blah, blah. If I use the round off rule, my round off rule, all of my data is whole numbers here. So I'm going to round to the 10th place, which means I wanted to use the 7 to round up to the 2. And that means my mean is going to be roughly 26.3. Okay. Let's talk about the median. So here's the thing about finding the median of a stem and leaf plot. You could go through and cross them off from the ends. You could start at 1, then cross off the 6. Go to the next one, cross off the 3. Go to the next one, cross off the end of the previous row. Go to the next one, cross off the next one in, and keep going. You could do all of that if you wanted to. But you've got quite a large data set here. You're looking at 47 points. The median is truly going to be in the middle. So my median is going to be, I shouldn't put an equal sign because I'm not saying that it's equal to this. It's going to be 47 divided by 2. And let's see what that gives me. 47 divided by 2 is 23.5. So that means that there's 23 points below the median and there's going to be 23 points above the median, which means that my median is the 24th data point. So since I know that the median is the 24th data point, that's what I'm going to do. I'm going to count to the 24th data point. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So my median is going to equal the 24th data point, which in this case is 28. Okay, so there's the median. Now let's talk about the mode. Mode is what we see appearing the most. I'm gonna switch to a better green here. The mode is what we see appearing the most. So the one that I noticed the most was this 4. That appears 4 times. There's no other data that appears 4 times. There's one that appears 3, but you can't call that the mode because something appears more. So my mode here is going to be 4. And you don't have to put the 0 in front of it. I just did out of habit because the stem was there. And the last one, mid-range. Remember that mid-range is the middle of the range, literally. My mid-range is going to be equal to the lowest plus the highest divided by 2. That's 67 over 2. And 67 divided by 2 gives me 33.5. All right, so that's how I would find those things from a stem and leaf plot. You can actually work with the stem and leaf plot as it looks. The other thing that some people like to do is they like to go and take this data and recreate the list. You could go through and list them all out if you wanted to. 1, 2, oops, there's a 2, then a 2, and a 3, and so on and so forth. You could make the entire list all the way up to 66 and then find all of these things, but you don't need to. The beauty of a stem and leaf plot is that all of the data is retained, so I can see each individual data point in the leaves. All right, so that takes us to the end of our video for today. Thanks for listening. This is our last notes video for Unit 1. Thanks for listening, and I will catch you next time.